Welcome to Chopra's School of Physics. We will slightly have a recapitulation for the Coulombs Law, and then we have to come towards electric intensity, whether it is vector or scalar, similarly electric potential and their applications. So in the Coulombs Law, as I have written earlier, F is equal to 1 over 4 pi epsilon naught epsilon r q1 q2 divided by r square. This is further modified as F is equal to k divided by epsilon r q1 q2 divided by r square. And if you combine epsilon naught and epsilon r, then we can write 1 over 4 pi epsilon q1 q2 divided by r square. These are the three basic compositions of Coulombs law in MKS system. Now we can write like this, that if we take this number and if we divide this number by this particular number, these two numbers are divided. We mark it as equation 1, equation 2, equation 3. Now, if we divide 3 by 1, then we can write like this, that is F by F, that is equal to, we will write like this, K over epsilon r divided by, we are taking second and third equation, K over epsilon r, and we will write 1 over 4 pi epsilon. And here we will write q1 q2 divided by r square and divided by again q1 q2 divided by r square. So this whole function will cancel off. This number will be 1 equals to, this is q over epsilon r, so it will be taken as this number, k over epsilon r multiplied 4 pi epsilon. I have written k over epsilon r. So we can write k over epsilon r like this. It is divided by this number, so 4 pi epsilon, that will come in the numerator, and k will be written as 1 over, this will be 4 pi epsilon naught epsilon r multiplied 4 pi epsilon. This 4 pi will cancel off, and we will find here that epsilon is equal to, again, epsilon naught into epsilon r. So we got epsilon from the definition of Coulombs law. Well, now you are aware of all these things. Now we come towards intensity of electric field. To understand intensity of electric field, first of all we must know the diagram of intensity of electric field and the symbolic representation and the definition. Intensity of electric field is defined as force experienced by unit positive charge, that is 1 Coulomb charge, at a point within electric field. So whatever I have spoken, it is represented like this. Suppose Q is a source charge, and around the source charge we have drawn this boundary. This is called electric field. So Q is a source charge, is the field of source charge. A point is selected within the field, the point is P, at distance R from the source charge, and this point P accommodates unit positive charge, and this unit positive charge is assumed to be Q naught, that is test charge. So now what will happen? Q give rise to field, field will exert force, and force will act on unit positive charge here. So force experienced by unit positive charge K Q1 Q2 divided by R square. Now this can be written as K. For Q1 we will write Q, and for Q2 we will write 1 divided by R square. So force experienced by unit positive charge equals to KQ by R square, that is for air medium because we are using K, or we can write 1 over 4 pi epsilon naught Q over R square, or we can write this number replaced by 9 into 10 to the power 9 Q divided by R square. So like this we can write these numbers. There is force experienced by unit positive charge 1 by 4 pi epsilon naught Q by R square, or this is written as 9 into 10 to the power 9. General formula will be applied general formula applied to any medium, for any medium, that will be F is equal to 1 over 4 pi epsilon naught epsilon R Q divided by R square. Now this force which we have written, that will be taken as electric field intensity. Electric field intensity. See, I'm putting arrow over E. It is electric field intensity. E stands for electric field intensity, or intensity of electric field. It is a vector quantity. Vector quantity. Its magnitude is calculated. Magnitude of E calculated by Coulombs law. Coulombs law. So this is about intensity of electric field, force experienced by unit positive charge, where at a point within electric field due to source charge at a given distance. So you will remember that from this point the electrical line of force is passing like this. Electrical line of force is passing. If we draw a tangent here, that is the direction of intensity. So tangent, if we draw here at a point on the curve, it will be direction of intensity of electric field. So now you remember the magnitude of the electric intensity is given by Coulombs law, and direction is estimated by selecting a point on the electrical line of force and then drawing a tangent. So on a curve at one point only one tangent can be drawn, and the direction of that tangent, that will be intensity of electric field. So this is all about the intensity of electric field, and this all discussion we have done in MKS system. So electric intensity in MKS, this is MKS or SI. In CGS system, electric intensity is simply Q over R square. That is, here electric intensity will be dynes per ESU of charge. But here electric intensity in MKS, there is the force. So electric intensity will be in Newton per Coulomb. So these formulas are for intensity of electric field. We have applied Coulombs law, where the medium is not specified. We have to take epsilon r. If it is air medium, epsilon r must be 1, and 1 over 4 pi epsilon naught can be taken as k, and k can be taken as 9 into 10 to the power 9. Thank you.